This is a video from section 3.3. Recall, the derivative of sine x with respect to x is cosine x. The derivative of cosine x with respect to x is negative sine x. The derivative of tangent x with respect to x is secant squared x. The derivative of secant x with respect to x is equal to secant x times tangent x. The derivative of cosecant x with respect to x is negative cosecant x times cotangent x. And the derivative of cotangent x with respect to x is equal to negative cosecant squared x. This is a review of the derivatives of the 6 trigonometric functions. I definitely recommend utilizing flashcards to help you remember these. Now, let's take a look at the product rule. The derivative of f of x times g of x with respect to x is equal to f of x times the derivative of g of x with respect to x plus g of x times the derivative of f of x with respect to x. And one way that it might help to remember this is I very much informally write this as follows. I'm going to take the first function, which is f of x. I'm going to multiply by the derivative of the second function with respect to x. And the second function is represented by g of x. And then I'm going to go plus the second function, g of x, times the derivative of the first function with respect to x. And remember, the first function is represented by f of x. It's a way to perhaps help you remember. And for the quotient rule, we have the derivative of f of x divided by g of x is equal to g of x times the derivative of f of x with respect to x minus f of x times the derivative of g of x with respect to x divided by g of x to the second power. And I'm going to rewrite the quotient rule as follows. So I'm going to take the second function, which is g of x, and multiply by the derivative of the first function. The first function is represented again by f of x minus the first function times the derivative of the second function. And then I'm going to divide by the second function squared. So perhaps it might be a helpful way to remember the quotient rule. And with that, the directions say to differentiate. And we're going to take a look at number 16. Suppose f of t equals cosine of t divided by e to the t. And I want f prime of t. Well, that's equal to e to the t times the derivative of cosine of t with respect to t. So you might notice I'm going to be applying the quotient rule. And then I'm going to take cosine t, multiply that by the derivative of e of t with respect to t. And I'm going to divide by e to the t squared. And so this is e to the t. Now, I'm going to multiply that by the derivative of cosine t with respect to t, which in this case is negative sine t, minus cosine t, times the derivative of e to the t with respect to t, which is e to the t. And I'm going to divide by, if you don't mind, e to the t times e to the t. Now, in the numerator, I'm going to factor out in e to the t. So f prime of t is e to the t times negative cosine t minus sine t. I'm going to divide by e to the t times e to the t. But I can cancel e to the t like so. And so this is going to equal negative cosine t minus sine t divided by e to the t. It's very important that we work on simplifying our derivatives because the ability to simplify will become important when we reach chapter 4. So I would always make it a habit to simplify our derivatives. And that's number 16. Let's take a look at number 18. So on 18, we have y equals sine t divided by 1 plus tangent t. And we're going to differentiate with respect to t. And once again, we're going to apply the quotient rule. So I'm going to write the bottom function, which is 1 plus tangent t. And I'm going to multiply by the derivative of the top function with respect to t. So in other words, I'm going to multiply by the derivative of sine t with respect to t minus sine t times the derivative with respect to t of 1 plus tangent t. And I'm going to divide by 1 plus tangent t to the second. And so this is 1 plus tangent t times the derivative of sine t with respect to t is equal to cosine t minus sine t times the derivative of 1 plus tangent t with respect to t is secant squared t. Now remember, the derivative of 1 with respect to t is equal to 0. Remember, 1 is constant, okay? And I'm going to divide by 1 plus tangent t to the second. Now, we can simplify this. So I'm going to distribute the cosine t inside. And so we get cosine t plus tangent t cosine t, right? And then I'm going to subtract sine t times 1 over cosine squared t. And I'm going to divide by 1 plus tangent t to the second. And so this is cosine of t plus tangent t times cosine t minus, now I'm going to write this as tangent t times secant t divided by 1 plus tangent t to the second. And that's not bad. I would perhaps do something further to the numerator if every term, let's say, had a cosine of t or a tangent t as a factor. But that's about all I'm going to be able to do for problem number 18. And so, therefore, y prime is cosine t plus cosine t times tangent t minus, and I'm going to write this as secant t times tangent t divided by 1 plus tangent t to the second. That's number 18. Let's take a look at 19. Suppose y equals t times sine of t divided by 1 plus t. And I want y prime, so I want the derivative. So I'm going to apply the quotient rule, but within the quotient rule, I'm going to apply the product rule, as you'll see shortly. So I'm going to write down the bottom function, which is 1 plus t. I'm going to take the derivative of the top function with respect to t. So in other words, I'm going to take the derivative of t sine t with respect to t minus t sine t times the derivative with respect to t of 1 plus t, okay? And I'm going to divide by 1 plus t to the second. And so this is 1 plus t times, I'm going to write the first function, which is t, and multiply by the derivative of the second function, which is cosine of t. So I'm applying the product rule here. And I'm going to add sine of t, so I'm going to take the second function and multiply by the derivative of the first function. I'm going to subtract t sine t. The derivative of 1 plus t with respect to t is 1. I'm going to divide by 1 plus t to the second. And so I'm going to multiply this out. So I'm going to take 1 times t cosine t, which is t cosine t. And then I'm going to add sine t. And then I'm going to add t squared cosine t. Plus t sine t. And then don't forget, I have to subtract t sine t in the end. And then I'm dividing by 1 plus t to the second. But the t sine t's cancel. And therefore, we have the following. Y prime is t cosine t plus t squared cosine t plus sine t divided by 1 plus t to the second. That's number 19. If we take a look at 21, suppose f of theta is theta cosine theta sine theta. And I want the derivative with respect to theta. So in other words, I want the derivative of f of theta with respect to theta. Now, what I'm going to do is I'm going to put parentheses around cosine theta times sine theta. And I'm going to apply the product rule. So I'm going to take the first function. I'm going to multiply by the derivative of the second function with respect to theta. Okay? And then I'm going to add cosine theta sine theta times the derivative of the first function with respect to theta. And if you notice, I have to apply the product rule again. So I'm going to take theta times, write the first function, and that's cosine theta, and I'm going to multiply by the derivative of the second function with respect to theta. So I'm going to multiply by cosine theta. And I'm going to add sine theta times the derivative of the first function with respect to theta, which is negative sine theta. And then from here, I'm going to add cosine theta, sine theta. And remember, the derivative of theta with respect to theta is 1. So the second term is just cosine theta, sine theta. So this is theta times cosine squared theta minus sine squared theta plus, and I'm going to do something a little sneaky on you guys. I'm going to rewrite this as 1/2 times 2 sine theta cosine theta. Now, we should recognize that cosine squared theta minus sine squared theta is equal to cosine 2 theta, right? I hope. So I can write this as theta cosine 2 theta plus 1/2. Now, we should recognize that 2 sine theta cosine theta is equal to sine of 2 theta. So I'm going to write this as theta cosine 2 theta plus 1/2 sine 2 theta. And that's how we do 21. The directions say, find an equation of the tangent line to the curve at the given point. And with that, we're going to take a look at 27. Suppose the curve is y equals sine x plus cosine x. And the point is the ordered pair 0, 1. Now, first, we want to find y prime, because what we need is the slope of the tangent line at the point 0, 1. So we need the slope. We already have the point. Once we have the slope and we know the point, we can get the equation. Now, y prime is equal to cosine x minus sine x. Now, at x equals 0, y prime is equal to cosine of 0 minus sine of 0. Now, cosine of 0 is 1. Sine of 0 is 0. And 1 minus 0 is 1. And so, therefore, we're given slope 1, right? That's the slope of the tangent line. And ordered pair, or we'll just call it point for short. So we'll just say given slope 1 and point 0, 1, we can get the equation of the tangent line. They all work like this, by the way. And so here, if we don't remember, when in doubt, you can do this. Y equals mx plus b. Okay? That's the slope-intercept form of the equation of a line. Okay? Now, m is 1, right? That's the slope. So we know that y equals x plus b. But when x is 0, y is 1, right? And so 1 equals 0 plus b. And that tells me b is 1. And by the way, that's not a coincidence, right? That's the y-intercept. So that's not a coincidence. And so that implies y equals x plus 1. And that's the equation of the tangent line. And that's problem 27. If we take a look at problem 28, suppose y equals x plus sine x. And the point here is pi pi. Y prime is 1 plus cosine x, right? The derivative of x is 1. The derivative of sine x is cosine x. Now, at x equal pi, y prime is 1 plus cosine pi, but cosine of pi is negative 1, right? And 1 plus negative 1 is equal to 0. Therefore, y prime is 0. So we're given slope 0 and point pi pi, okay? Now, to get the tangent line, and again, we could do it the same way the whole time. Now, the slope-intercept form of a line is y equals mx plus b. And m is 0 this time, so y equals 0x plus b. Now, when x is pi, y equals pi. That's what it means to be a point on the line, right? It's got to satisfy, it's got to be a solution to the equation of the line. And so pi is 0 times pi plus b. But that tells me b is pi. And so what that says is y equals pi. It's a horizontal line, right? And that makes sense because we want the slope to be 0. And that's how we do problem 28. If we take a look at 29, suppose y equals e to the x cosine x plus sine x. And the ordered pair here is 0, 1. And so y prime is e to the x, so I need to do the product rule on the first term. And I'm going to multiply by the derivative of the second function with respect to x. So in other words, I'm going to take e to the x times negative sine x. I'm going to add cosine x times the derivative of e to the x with respect to x, which is e to the x. And then I'm going to add the derivative of sine x with respect to x, which in this case is cosine x. At x equals 0, y prime is e to the 0 times negative sine of 0 plus cosine of 0 times e to the 0 plus cosine of 0. And so this is sine of 0 is 0, and cosine of 0 is 1, right? So 1 plus 1 ends up being 2. So y prime ended up being 2 at x equals 0. So we are given slope 2 and point 0, 1. Now, to get the tangent line, and I'm going to solve them the same way. And you could use the point slope form. That's fine. There's a lot of different ways to get the equation, right? So y equals mx plus b, okay? M is 2, so y equals 2x plus b. When x is 0, y is 1, so 1 equals 2 times 0 plus b. That tells me b is 1, And that tells me that y equals 2x plus 1 is the equation of the tangent line. And that's how you do problem 29. And for the last one for this video, if we take a look at problem 30, suppose y equals 1 plus sine x divided by cosine x. And the ordered pair here is pi negative 1, y prime. So this is quotient rule. So we get cosine x, that's the bottom function, times the derivative of the top function, which is, in this case, is cosine x, minus 1 plus sine x times the derivative of cosine x with respect to x, which is negative sine x. I'm going to divide by cosine squared x. And so this is cosine squared x minus sine x, and then plus sine squared x divided by cosine squared x. But cosine squared x plus sine squared x is equal to 1. And so y prime is 1 minus sine x divided by cosine squared x. At x equal pi, y prime is 1 minus sine of pi divided by cosine squared of pi, which is 1 over, remember sine of pi is 0, divided by negative 1 to the second. Cosine of pi is negative 1, so you get 1. So we're given slope 1 and point pi negative 1. We can get the tangent line. So we get the following. We know y equals mx plus b. And remember, m is 1. So y equals 1x plus b. When x is pi, y equals negative 1. So negative 1 is pi plus b. So b is negative 1 minus pi. And so therefore, y equals x minus pi minus 1 would be the equation of the tangent line. And that's going to conclude this video for section 3.3. We worked on problems 16, 18, 19, 21, 27, 28, 29, and 30. Thank you.